Hi class, so let's just do a recap on this week's physics lesson, okay? So we looked at some keywords. We looked at a new one, which is velocity, and then we looked at speed. We know distance, we know time, we know gradient a little bit, we know acceleration. We surely know what homework is, and also we know deceleration. Okay, as in we looked at these keywords. So let's just go through what we went through this week, okay? Okay. Acceleration refers to the change in velocity over a period of time. Okay, so change in velocity or final minus initial velocity, in other words, okay, divided by the time taken for the change to happen. So v is the final velocity, u is the initial velocity, you minus it and you divide it by time. Okay, now remember, acceleration can be a negative as well if the object slowed down. So negative acceleration is called deceleration. Okay, the unit for acceleration is meter per second square. Why is it meter per second square? Is because you are dividing velocity with time. But velocity or speed is already distance over time. So distance over time, divide by time again. So you have two time units at the bottom. Why? So because there are two time units, so that's why it's meter per second square. Okay, let's look at this graph. Let's look at specific points on this graph. Okay, this is a velocity time graph. So as time goes by, the velocity, remember velocity is speed, but with a direction. But it's the same as speed. We are referring to the same thing, just that now we have a sense of direction to the speed, so we call it velocity. So let's look at E. E, as time goes from 0 to 4 seconds, the velocity stays less than 5, it stays at 4. So because the velocity is staying at 4, it's not that it's not moving, the speed is there. The speed is just 4 the whole time. So that means at E, the acceleration is 0. Why? Because the speed is the same. It's not moving faster. Acceleration is only if something moves, changes speed and move faster. But this one, the speed is not changing. It's just at 4 only. So because of that, the acceleration is 0. So it's not accelerating. Then we look at F. Okay, F from 4 to 10 seconds, that is altogether 6 seconds. And then it's going from 4 to 10. The initial velocity is 4, the final velocity is 10. So remember, acceleration is final minus initial, so 10 minus 4, divided by the time taken, which was 6 seconds. So 6 divided 6 is 1. Let's look at G. G, the speed is going down, so acceleration is negative. So it's a deceleration. But let's just look at the maths. So 10 going down to 7 meter per second. So the final is 7, the initial is 10. That's why 7 minus 10, not 10 minus 7, because the final is, this is the final point. So 7 minus 10 divided by the time was 6 seconds. So I get negative 0.5. Remember, negative acceleration is deceleration. And then H. H is going from 7 meter per second to 21 meter per second. So 21 minus 7 divided by 16 to 20 is 4 seconds. So you get 3.5 meter per second. So remember, final velocity minus initial velocity. Okay. So here are some questions. You can take time to redo these questions if you want to have a better understanding, but we did do this in class. Okay. Okay, then we looked at terminal velocity. We looked at it very shortly, but let me just go through it in this video. Terminal velocity is the greatest speed that a falling object can reach. So remember I said terminal velocity is after a while, the parachutist will come to a steady speed and then it will reach the ground slowly. So that at that point, that is the greatest speed. He cannot go faster, he cannot go slower. It will be that speed only. So this is a velocity time graph. See, over a period of time, the velocity will stay the same after a while. The parachute will just be at one speed only until it reaches the ground. So that this part here, this horizontal line part here, means that it has reached terminal velocity. Okay, so when an object starts to fall, the only force acting on it is gravity. Okay, parachute free falling object means what we say is this is a free falling situation. So it just falls only. The parachute, the guy who's skydiving just falls. and gravity is the one pulling him down. Okay? So let's look at this. Once these are imagine, I'm not sure if any of you have skydived before. I don't think y'all can yet. But once the parachutists start moving, okay, jump from the plane, there will be air resistance, correct? Gravity will be pulling him down, but air resistance will be pulling him up. So as he gains gains speed, the air resistance or drag on him increases more and more, but the force of gravity stays the same. So as he's falling, gravity is pulling him down, but the force that is pulling him upward starts to increase as well. But gravity is the same. Okay? Because as he's falling, the speed is increasing. Okay? So when those two forces become equal, up and down become equal, let's see the one before. A little bit, slightly more, and then more. This force is the air resistance and drag. When the forces are pulling him up and the forces pulling him down are equal, okay, that means they're balanced. That's when the parachutists start moving constant at a constant speed. Okay, so when will there be force pushing him upwards is when the parachute open. So here, it doesn't show the parachute open, but what happens is he falls, he drops, gravity pulling him. Suddenly he opened the parachute. So when you open the parachute, he'll be pulled up. Why? Because there's air resistance, there's drag that is pulling the parachute, because the parachute's like a cloth. There's a big surface area, a lot of air resistance. So pull him up. So one force pulling him down, one force pulling him up. Finally, they decide to work together and they're both balanced. So does the parachute stop moving just because it's balanced? No, imagine the fellow's it's just floating up there, just stays stagnant up there. No, the forces are balanced. He's not stopping from moving. He hasn't stopped from moving. It's just that he's now at a steady speed. Okay? So this is when we say the parachutist has reached terminal velocity. Okay? So yeah, that is all. Thank you. Bye-bye.